To complete the mid-chapter checkpoint, we're actually going to start with one that you were able to skip over. So for 25, if we are looking at the sine squared of pi over 2, that's really the sine at pi over 2, and then I square it. And then I subtract the cosine at pi. So you really can look at your unit circle. Again, the sine at pi over 2 is 1. So 1 squared minus the cosine of pi is -1. So 1 squared is 1. And if I'm subtracting a -1, I'm really adding 1. So that answer ends up being 2. For 26, this is more unit circle. The cosine at 5 pi over 6 is the square root of 3 over 2. No matter how many times I spin, which is what that plus 2 pi n means. So 3 circles, 4 circles, whatever it might be. The tangent at 5 pi over 6, sine over cosine, would be 1/2 divided by the square root of 3 over 2. So this really is just this little bit of manipulation. So I have my square root of 3 over 2. This simplifies to 1 over the square root of 3. This really is a test in fractions, which when we rationalize, we've seen as the square root of 3 over 3. I need a common denominator of 6 to be able to add these guys together. So 3 square roots of 6 over 6, the 3 in my 6 in the denominator simplify to 1/2. And so that would be plus 2 square roots of 3 over 6, because 2/6 is the 1/3 in the denominator. So when I add 3 square roots, sorry, too many 6's. 3 square roots of 3 plus 2 square roots of 3, I have 5 of that quantity divided by 6. So the square root of 3 shouldn't have changed. It was just that dividing by 2 is the same thing as 3 over 6, because that's a 1/2, and then my dividing by 3 is 2 over 6, because that's 1/3. So 5 square roots of 3 over 6 is what I end up with for that one. 27. If a circle has a radius of 40 centimeters, and I want the length of the arc, so S is r times theta, but theta's in radians, and this is giving me a central angle of 36 degrees. That means that when I find my arc length S with 40 centimeters, my 36 degrees, I have to convert to radians, which we did by multiplying by pi over 180. That was our warm-up for us. 36 and 180 actually reduces to 1/5. And so 40 pi over 5 is 8 pi. Or to the decimal places, 8 pi is 25.13 centimeters. And 28 was another one we could have skipped. A merry-go-round makes 8 revolutions per minute. That sounds like a fast merry-go-round for some reason. And so that's my speed, 8 revolutions per minute. And the horse that is 10 feet from the center, that's a fancy way to identify the radius. Each revolution that this makes is a full circumference. And circumference, if you remember from geometry, is 2 pi r. And so that's where that 10 comes into play, because that's the radius. And so this really is just dimensional analysis. 8 times 2 times 10 would be 16 times 10, or 160 pi. And that was in feet per minute. As a decimal point, if I want to take 160 pi in my calculator, that gives me about 502 feet per minute. And so, again, some new formulas, some old formulas, just recognizing what that all refers to. My plane. The plane taking off. A plane takes off at an angle of 6 degrees, so not a crazy steep angle, and it travels for a mile, or 5,280, that's one of my favorite numbers. Along this flight path, find the height. So what is my height to the nearest foot above the ground? So this is another SOHCAHTOA problem. If that's a right triangle. My 6 degrees, the x is opposite from it, and the 5,280 is my hypotenuse. I don't care about the distance along the ground, which would be my adjacent side. Opposite hypotenuse would be the sine of 6 degrees equals x over 5,280. So if I multiply 5,280 by the sine of 6 degrees, again, making sure that my calculator is in degrees to the nearest tenth of a foot, it is 551.9 feet above the ground after 1 mile. And then my tree. My last problem with my tree. I have a tree that is 50 feet tall, and it casts a shadow that is 60 feet long. And then what is the angle of elevation up to my sunshine up here? So I'm looking at this angle in the bottom corner. So my hypotenuse isn't labeled, don't care about it. My 50 is my opposite. So the tangent of my angle is equal to my opposite side, my height of 50, divided by my adjacent side, which is the base of the triangle at 60. To undo any trig function, I can't simply add, subtract, multiply, divide. This is where the inverse comes into play. So needing a calculator, I hit second tangent to get the tangent inverse. And again, making sure I'm still in degree mode of that, I, to the nearest degree, end up with, instead of 39.8 degrees, I would round that to 40 degrees.